Weather satellites in space and humans on Mars. You're listening to Are We There Yet? The radio show exploring space exploration. Hi, I'm Brendan Byrne. A new satellite will soon be able to track extreme weather from more than 20,000 miles above Earth. From hurricanes in the atmosphere to volcanoes in the ocean, the Geostationary Operational Environment Satellite, or GOES-U, will help people better understand and prepare for Earth's biggest environmental threats. We'll speak with one Lockheed Martin engineer about this new space satellite. Then, just how close are we to putting humans on Mars? From the floor of MegaCon Orlando, our friends at the podcast Walkabout the Galaxy hosted a discussion on the challenges and possibilities of living and working on the Red Planet. That's ahead on Are We There Yet? The National Oceanic and Atmospheric Administration and NASA have joined forces to launch an advanced weather satellite. This satellite is the final in a series from NOAA. GOES-U has a targeted launch date set in April of this year. The satellite will study climate data and monitor Earth's most destructive environmental phenomenon, like wildfires, volcanoes, and hurricanes. Here to talk more about what this satellite is capable of is Ryan Page, an engineer with Lockheed Martin. Ryan, welcome to the show.
Oh, well, thanks for inviting me. It's awesome to talk about GOES.
Awesome to talk about GOES indeed, which is launching very soon. But before we get into the kind of nitty-gritty about this satellite, let's talk about kind of its bigger purpose and really where it fits into the mission of observing our planet from above. What's its intended purpose?
Yeah, so this one that we're going to be talking about is GOES-U, soon to be GOES-19 a little bit later this year when it reaches its final destination in geostationary orbit. But these are really just, in my personal opinion, and the opinion of our whole team, they are the world's best weather observation satellites. So this particular vehicle is a 7-payload vehicle carrying a whole suite of instruments designed to better understand both Earth and space weather.
How is it even possible that you are able to get images of the Earth like this that are so crisp from these satellites? It really is mesmerizing.
Really, it is the most sophisticated form of weather sensing we can build. You're talking about a 15-year mission life. So they actually plan life of 10 years, but we build them for 15. So they're these giant, hardy satellites with the best possible technology equipped to them. So we work as Lockheed Martin as one of the prime contractors with a lot of best-in-class vendors to put this thing together with the best possible hardware, software, and build it just for that intent, that 10-year mission life. It is infrastructure in geostationary orbit is how we see it. So these images you see are a combination of just the incredible amount of sensing that some of these payloads can do. I mean, you're talking about an advanced baseline imager, which is really the big payload on our vehicle. It's built by L3 Harris. So it sees in basically 16 different light spectrums, 2 visible, 4 near infrared and 10 infrared, and it stacks all that data together to get you those pretty pictures. You know, some of the stuff it can do between taking full images of the whole United States every 5 minutes to almost down to 2 minutes is just an incredible sensing power of that hurricane tracking, that extreme weather tracking.
It is more than just pretty pictures for people other than me, and we'll talk about that in a moment, but you mentioned something about infrastructure in geostationary orbit. Let's talk about the orbit that the satellite is going into and why it's so important.
Part of the mission it goes is, right, you're getting to geostationary orbit. That's a very, very far way away. That's over 22,000 miles away. So it is a haul to get there with a combination of our launch vendor SpaceX and then the liquid apogee engine on the vehicle. We get to that 22,000 miles, and this particular satellite, GOES-U, will move into the GOES East point of our constellation. So we have a GOES East and a West. From that very far away vantage point, those incredible sensors on our Earth pointing platform can see all the way from Hawaii to the west coast of Africa. So you're talking about a giant field of view. And the only way you get that is by getting really far away.
And it also doesn't actually orbit the Earth, so to speak, right? You're looking at the same spot over the same amount of time, right?
Correct. Geostationary, right? So you basically get into a longitude and latitude at that very far distance. And our incredible work from our guidance and navigation and propulsion team has built these things with a suite of thrusters and reaction wheels so they can maintain their station, right? And their station is to travel along in this location, so you're constantly monitoring from this vantage point.
I've always known that geostationary orbit is far away, but 22,000 miles, that's pretty far when you think like the International Space Station is something like 100 or 200 miles up, right? I mean, that's pretty far away.
I mean, getting to that, we have multiple stages along the way, multiple burns of our liquid apogee engine to get there. And then once you get there, it's station keeping, right? Our vehicle houses 32 thrusters for a reason, right? You have to get there, and then you can't let yourself drift away. You have to maintain your focus on your Earth pointing platform and those Earth sensing instruments that you're looking at your destination.
For folks that are listening to us here in Florida, they're very familiar with GOES images, especially around hurricane season. As you mentioned, forecasters use them to track storms. What other kind of weather phenomenon or atmospheric phenomenon is this satellite and the satellite constellation able to track?
People in Florida, hurricane tracking is the number one, right? You can see all those. I feel like it's improved with the advent of this technology and its slow integration into meteorology, right? But you're talking about from us local, and the satellite was built in Colorado. We're talking about everything from snowstorm tracking to wildfire tracking. One of the amazing things we do that I like to talk about here in Colorado is when you pull up your Google Maps and you're going to go for a hike on the weekend, you can actually see where active wildfires are because of our satellites, because they're actively tracking it, pumping that data into Google Maps. So you can actually see, oh, my route is closed. Oh, this area is closed, because literally we're seeing a real-time fire. To know that each one of these satellites pumps down about a terabyte of data a piece a day. That's more data than we know what to do with right now. But the goal is in 5 years, in 8 years, we'll know what to do with that data, and it'll help us sense more things that we can take in now.
5 terabytes of data being beamed down from 22,000 miles above. That's just insane when you think about it. I mean, how are you even able to communicate and get that much data back from a satellite that is so far away from us?
When I talk about this being space infrastructure, that's what NASA and NOAA have really built this out to be. So this downlink system they have based out in Nesdis in Maryland is very sophisticated. They're always in communication with these satellites, right? So we have a suite of antennas that help with that uplink, downlink, that constant share of information. So they've just built this sophisticated infrastructure that has really allowed them to maximize the data downlink from these.
So you talked about hurricane and weather forecasting, monitoring like wildfires in almost real time. I'm also reading that this is able to even identify volcanic eruptions, even ones that happen underneath the ocean floor. I mean, that's just incredible.
So a couple different points of tracking there, right? It can actually see the changes in light from the different light spectrums, and then it can also track the volcanic ash as it slowly comes through to the surface. So absolutely unbelievable. My other fun fact was like a theory. I'm fortunate enough to be with this program since GOES-R was launched. So they always had speculation that could do this, but they launched GOES-R in 2016, and then sure enough, they could see bolides. So you can see actually asteroids entering Earth's atmosphere. So you can actually track meteors with this too.
So these are multiple kind of sensors and instruments that are on the satellite that's doing this. How big is the satellite itself, and where do these kind of instruments fit onto it?
We like to say it's kind of about the size of a bus, roughly. So it's going to be just shy of a dry weight of just shy of 6,500 pounds. When we fly it, it's going to be just shy of 12,000 pounds. So it's about half fuel. So it's a big thing. It's a school bus, right? This particular vehicle has 7 instruments. The previous 3 vehicles have had 6. The main payloads are really our Earth pointing platform. That's going to house our advanced baseline imager. I talked about that before. That has our basically the world's greatest DSLR. Its partner on our Earth pointing platform is our geostationary lightning mapper. That's built by Lockheed Martin. What's really special about that is GOES-R is the first suite to actually have geostationary ones, so they can actually, map along the coastline and watch historical trends of lightning, right? It also is really nice because lightning is a really good indicator of storm intensification, right? So when you see hurricanes or tropical storms rising in categories, you actually see increased output of lightning. So it actually better helps predict when stores are evolving and downgrading. That's really on our Earth pointing platform. The backside of GOES, which doesn't get as much publicity because obviously we care about Earth weather, is our space weather suite. So on our solar array, we actually have an articulating platform that points towards the sun, and GOES-U houses 3 payloads. So it's going to be our solar ultraviolet imager, which looks at the sun in ultraviolet light conditions, our Axis, which is an extreme X-ray irradiance sensor, which basically looks for coronal mass ejections, solar irradiance, and then New to goes you is our compact coronagraph CCOR, and that is really cool because it actually looks at those coronal mass ejections and kind of categorizes them. So a coronagraph is basically an artificial eclipse, right? So it puts a disk over the sun so we can actually see what trajectory and volume those coronal mass ejections are pushing out and track them a little bit better to see how they're impacting Earth's weather and environment. And then we got even more instruments on it on the backside of the satellite that actually work to monitor geostationary orbit. So like I said, a lot of infrastructure is in geostationary orbit because you can keep it in a location. But that also means we got to see what that location does to our infrastructure. So we have a magnetometer, which basically reads the magnetosphere of geostationary orbit, so that electron-proton exchange. And then we have a SICE, which is like an in-suite, which basically is constantly reading both push and pull of intergalactic electrons and protons into Earth's magnetosphere and geostationary orbit. So 7 instruments, a bus-size vehicle. It's a really awesome satellite, man. It's so cool to work on.
I just, as you were talking, I Googled a picture of it, and my goodness, that thing is big. It's a massive satellite.
It's incredible, right? So fortunate enough to work on it for a number of years, and you kind of lose the scale. I've been able to go work on some of the deep space missions and go look at some of those vehicles. They're incredible. But the craziest thing is they're the size of a dishwasher. And you walk back, and I'm working on this vehicle that one of the payloads is the size of a dishwasher. It's a piece of infrastructure. We build them and test them very rigorously, right? It's not lost on our team or on the customer about what the goal is, right? The goal is this incredibly valuable piece of technology that is supposed to help U.S. citizens and save lives for 10 years. And we build it that way, and we test it very hard, and we put those instruments through its paces. That's what we're doing now down in Florida. Before we launch it, we got to make sure before this thing flies up there that we've crossed all the T's and dotted all the I's.
And finally, Ryan, I'm glad you mentioned that because, before we started talking, you said you traveled down here to Florida with the vehicle. It's preparing for flight. When does it launch? How is it getting to space? And what can we expect in the time leading up to T-0 on this satellite?
So we do have a launch date, April 30th. That's going to be with our contracted vendor, SpaceX. So working with them pretty thoroughly. But obviously, that's a couple months from now. So what do we do, right? We've already shipped it to Florida. I kind of spoke with that earlier. I was fortunate enough to fly with the vehicle on a C5, one of the coolest experiences I've ever had. So we get it in Florida. We get in a safe clean room for rent called Astrotech. And what we do is checkouts, right? We have built it. We have tested it. Now it's time to do one last stamp of approval before we get into orbit. So that includes final instrument testing, final launch orbit raising preparedness, then final thermal insulation. Then we do our propulsion system checkout. I mentioned earlier, 32 thrusters. That involves a lot of propulsion. So we validate that system one more time. We do our fueling, and then we move into encapsulation, and then eventually we hand over the vehicle to integrate into the rocket. So it's a lot of small steps, but they're big milestones, right? 10-year mission life. Make sure your instruments work. Make sure your propulsion works. Make sure you're encapsulated correctly. Make sure you're thermally insulated. Again, geostationary orbit, you're going through everything. You can't get out there and fix it. So it has to maintain its thermal stability while it's in that orbit. So a lot of final checkouts to make sure that we meet that 10-year mission life.
We were speaking with Lockheed Martin's Ryan Page. Ryan, cannot wait for you to get this satellite off the ground, and I cannot wait to spend countless hours staring at the beautiful images that come back down to Earth. Thank you so much for chatting with us, Ryan.
Me and you both. Appreciate it, Brendan. Anytime.
Still to come.
People will go to Mars. We've been talking about how difficult it is to get back from Mars. Well, why not just eliminate that part of the problem?
How close are we to stepping on the surface of Mars? That's ahead on Are We There Yet? You're listening to Are We There Yet? I'm Brendan Byrne. Just how close are we to putting humans on Mars? That was a question posed by the hosts of the podcast Walkabout the Galaxy. Earlier this month, I joined that show for a live taping from the MegaCon Orlando convention floor. Here's a portion of that conversation with me and hosts Josh Colwell, Audrey Martin, and Jim Cooney.
let's imagine that we are there yet, fellow astroquarks.
Right. We're on Mars.
Let's project ourselves forward into the future. We can go to Mars. You're each going to go to Mars. Where on this big red planet do you want to go?
Brendan?
I would like to go to Jezero Crater.
Jezero Crater,
that's a good
which is
one.
where
Perseverance is
rover is right now.
It's the only location on Mars that I can memorize. So that's where I'm going there. But it's a really, really cool spot, and scientists think that there was life there at one point. So there might be life there when I go to live on Jezero Crater. So,
okay, so you're hoping to bump into some Martians.
I'm hoping to bump into some Martians, make sure there's some water, some oxygen there. Yeah.
Okay.
Yeah, that'd be nice.
Audrey, where do you want to go?
I mean, that is a good
It's a
location,
beautiful spot.
because even if you go there and you're like, this isn't great, you know that something else is going to go there to pick up the samples.
Or you got somebody to talk to.
And
Percy's there.
There, yeah. I don't know. I think I'd want to go to Olympus Mons.
Okay.
I just
Nice.
volcanoes are just really fun, and that's the only reason I want to go.
It is an extinct volcano, and it's like the size of Colorado.
It's the biggest. It's
yeah,
the biggest.
right. Jim, where are you going on Mars?
I'm hanging out with Brendan. Aliens all the way.
Okay, you're going to Valles
I'm going
Marineris.
fossil hunting.
You're
I'm gonna find
going
those shark's
Jezero
teeth.
Crater.
Yeah.
Okay, I'm going to what we've got up here on the screen, Valles Marineris, or maybe one of the ice caps, one of the polar ice caps,
that's
to
a good
kind of
spot.
do some cross-country skiing.
There you go.
Something like that.
Yeah.
That sounds really fun.
Okay, cool. Well, before we get to Mars, what's our journey to Mars? It's via the moon in some sense.
Got to go to the moon first.
We had our Artemis 1 launch about a year and a half ago, a little less than a year and a half ago.
Yeah.
What is going on? What is the status of our journey back to Mars, Brendan?
NASA's got this very ambitious plan to put humans on the moon through the Artemis program. We saw a very successful mission in Artemis 1. There was no people on board that one. That was an empty space capsule. Well, there was some...
Were there dummies?
There were dummies.
There were some mannequins on board.
We don't call them dummies. Or I'm not supposed to call them
They were
dummies.
smarties.
They were smarties.
People simulators.
Yes. And that went very well. The next mission is Artemis 2. That will have a crew of 4. So 3 NASA astronauts and 1 from Canada will be on board that one. But that one's going to take a little bit longer than NASA originally anticipated. It was supposed to launch at the end of this year. It's now looking towards the end of next year. That's because of a few different things happened. One, the heat shield took a little more damage than they originally anticipated on the Orion space capsule when it came back. Because, it hits the atmosphere pretty hard, pretty fast, creates a lot of friction. Mm-hmm. That heat shield there is to protect the mannequins in Artemis 1 and protect the astronauts of Artemis 2 and beyond. So they're looking into that. They also need a landing system. So there's a lot of things that need to come into place.
Artemis 2 is fly around the moon, snap some pictures out the window.
With people.
About a 2-week trip or so.
It's going to take 2 weeks?
Yeah.
Yeah.
I think so, yeah.
Whoa.
Yeah.
Then Artemis 3, what's our timetable for that?
That's a little iffy. So that will be after Artemis 2.
What?
And that's about as detailed as I can get.
We should totally reverse the order of those two, because Artemis 3 is a lot more interesting. So.
Still need a lander for that one. SpaceX is working on that with Starship. Starship will be the lander. They still need to get that into orbit and demonstrate that they can transfer fuel back and forth before they get astronauts on the surface. Beyond that, SpaceX will have a few lander missions, and then it is open to other companies to provide another vehicle, whether it's SpaceX or another company that's going to provide more landers. Really, a lot has to go right in a very short amount of time, and NASA's not taking any chances. So they'd rather be safe than sorry when it comes to putting people on the moon.
So. That's definitely good.
So Artemis 3, you're not even going to hazard a date for that one.
I am not. No.
You can be wrong.
So
it's okay.
The architecture and then there is nominally an Artemis 4. And even an Artemis
during this
5.
entire process, they will put a mini space station in a very intricate orbit around the moon that will be used as a staging ground for moon missions, but also Mars missions, which we can talk about a little bit later. But all of that is happening at the same time. So there's a lot going on to get humans onto the moon. And that's only 250,000 miles from home? Only.
That's a 3-day trip instead of like an 8-month trip.
Exactly.
So it's a very different story.
Yeah. Didn't we do this in 1969?
We did do it in 1969.
Why is it so hard to get back?
Well, that's a very good question, Jim. It's because we're going to someplace completely different. So the moon missions of the 1960s and early 70s were to the equatorial region of the moon. The Artemis missions want to go to the South Pole region of the moon, which is far more difficult to physically get there, and it's also far harsher than the equatorial regions. It's colder. We believe ice is trapped under the surface,
which is
and it's
one
very
of the reasons
dark.
Why we want to go there.
One of the reasons we want to go there as well is to be able to collect that trapped water ice and use it for fuel and life support.
Frequently, when you hear about like finding water, we talk about it all the time. Oh, they found some water on the moon. Oh, they found some water on Mars. It's like, enough already. Okay, we know there's some water on both of these locations. Why is that so important? It's not because, the astronauts forgot to bring a bottle of water like I forgot to bring to MegaCon here. It's because, as you said, water is actually burnt rocket fuel that with some electricity you can unburn.
Mm-hmm.
Decompose it into hydrogen and oxygen. The hydrogen is rocket fuel. Mm-hmm. You burn it with oxygen. You reproduce that water and you get rocket thrust. Is this a reason why the moon is potentially part of the trip back to Mars?
It is, and it's to establish a solar system gas station, essentially, right? So you're able to make this fuel, make these supplies that you need, because it's very difficult and expensive to get mass into orbit and off this planet. So if you can make your fuel on the way to Mars, then that is a really cost-saving and mass-saving feature of your architecture. So that's exactly why NASA is interested in water on the moon.
But also in the 60s, we were like in this mad dash race.
It's all politics,
go
right?
plant the flag. Is there any of that going on now? And is there also like the issue of we want to have a little bit more of a sustainable infrastructure?
There is, and we recently heard from congressional leaders that there is a concern that we are in another space race with another country, and that's China.
Oh.
China has a very ambitious plan to land humans on the moon. They're landing robotic landers on the moon. They've got a space station that has a crew on it that's consistently crewed now, and congressional leaders grilled NASA and asked them, is China going to be a new adversary? So there is this kind of geopolitical space race happening once again, and there are concerns from our politicians that China will misuse the moon. So that's why they want to get there first.
Why does it have to be a race, though?
That's how you get money. That's
Yeah.
how you get
All right.
congressional money.
Okay,
Yeah, that's
fair
how
enough.
you get funding.
Yeah. And they are also focusing on the South Polar region for
They
the
are,
same reasons
yes,
that
yeah.
NASA is. The number of missions just to get like a briefcase worth of samples back from Mars is kind of astonishing. Like Perseverance is doing, okay, I've collected some samples. Mm-hmm. Then nominally there's an Earth return orbiter mission that gets launched. Then there's 2 more missions that need to be launched to get something down to the surface. They can get something up to Martian orbit that then can transfer something to bring it back to the Earth. There's we don't send stuff to Mars every day. This is like multiple launches just to get a briefcase.
And we've never sent anything back from Mars.
Right, exactly. And I think it's really cool too because Perseverance is a NASA mission, but NASA is asking other space agencies around the world for help, for collaboration. And so ESA, the European Space Agency, has, I think, agreed to help. And I think now JAXA might be involved in this in some way.
Japanese Space Agency.
Yeah, the Japanese Space Agency. And there's more and more space agencies that are kind of popping up around the world, so maybe they'll help out too. So it might be like a nice global healing kind of moment.
Yeah. It's also because it's really expensive.
Well, that too, but also healing.
Like tens of billions
and
of dollars.
Friendship.
Yeah, but it's expensive. We need to share the cost.
Well, I mean,
That
but I
too.
think what Audrey is pointing out correctly is that there are some ancillary benefits, non-scientific benefits, to everybody coming together to do something that is too challenging for any one entity, even NASA, to do on their own. We're talking about when will we walk on Mars. There have been a couple of projects for sending people to Mars permanently. Like there was this Mars One, was that what it was called?
No.
Actually, did you know one of my graduate students was one of the 100 finalists?
Really?
For the Mars One project? Yeah. So that obviously isn't happening. But that idea was people go to Mars. We've been talking about how difficult it is to get back from Mars. Well, why not just eliminate that part of the problem? Okay, so you send them to Mars, keep resupplying them with food and water and, new movies or whatever to keep them entertained, live on Mars. But, I don't know. Do you want to move to Mars,
No.
Jim?
No.
Okay.
No.
You can't go fishing there.
No. You leave everybody forever. Your kids, your wife.
You can't go breathing there.
Right,
but
yeah,
why do you not
exactly.
want to go to Mars?
What?
You said you leave everybody forever, and I said, yeah, but why do you not want to go to Mars?
Right. I am antisocial, and that would be kind of cool. But no.
Yeah, it just seems kind of
claustrophobic.
There's not a lot to
morbid in
do.
some way.
The dining options are very limited.
Yeah.
Yeah.
I don't think Uber goes there.
They don't
Not
have,
yet.
yeah.
Yeah, not yet.
So you want to get back. That's a huge problem. We talked about how difficult it is to get off the Earth. It's easier to get off the Moon. Mars is in between. On Mars, you weigh about 3/8 what you weigh on the Earth, so it's not as bad a situation, but it is challenging. Also, there's an atmosphere, that's sort of just enough atmosphere to get you into trouble.
Yeah.
You got to be careful about it with the friction coming in,
Yeah.
but it's so thin you can't really use it to stop yourself like we do
Well, you
landing
can
on
use
Earth.
parachutes, which is
But
nice.
not only.
Well, yeah, okay.
Yeah.
So maybe
Okay.
before we
So
do
far.
the trivia answers, we should just say, what year do you think we'll land on Mars with people?
Okay.
Go.
2064.
Oh my God, I'm definitely going to be dead by then. 2053.
2050.
That's very optimistic.
Thank you.
I'm the cynical journalist. I'll say 2080.
2080.
Yeah.
Okay.
I think I could survive that long.
Yeah.
We may have some people in the audience who will make it to 2080. I'll definitely be around in 2080 for
Yeah.
sure. I know you will too, Brendan. Jim, not so much.
Not so much.
Yeah.
He'll be on Mars.
Okay.
That was a portion of the Walkabout the Galaxy podcast taping live from MegaCon 2024 in Orlando earlier this month. You can hear our full conversation by checking out the Walkabout the Galaxy podcast wherever you get this podcast. Special thanks to Chuck Lindsay for producing that conversation and MegaCon Orlando for the invitation. Well, that's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Subscribe on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. That's going to do it for this week's show. If you're not already, be sure to subscribe to this show's podcast feed so you never miss an episode. Subscribe on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. We got more space coverage online. Visit WMFE.org/space. Are We There Yet is a production of 90.7 WMFE News. Our producer is Marion Summerall. Our intern is Emily Ching. Editorial guidance comes from Latoya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.